Hello, thanks so much for having me here. You might not be able to tell from my accent, but as I was introduced, I was actually born and raised here, so very, very honored to be here for the last JSConf EU. So how was lunch? Was it good? Yeah, I thought it was pretty good too. I was choking it down because of nerves, but it's fine. So we're going to be talking about a pretty exciting new API that you might have accidentally discovered in your browser. It's called WebUSB. I'm going to try and give you a gentle introduction, but after I proposed this talk and it was accepted, I realized a more appropriate title was, how do you send a SIGINT in a browser? And so it's been an interesting challenge ever since. So I'm Suz Hinton. You can follow me on GitHub and Twitch and Twitter as like NoOpCat. If you'd prefer to call me NoopCat, that's also fine. I know some people were really sad when they found out it wasn't Noop. So I work on open source IoT libraries in my spare time, and then I actually get a salary from Microsoft during the day, and I do developer relations. And I mostly am concerned with IoT, but obviously that kind of goes hand in hand with things like machine learning and big data as well. So I sort of do a menagerie of things there to help smooth over the experience when you're using our tools. So today's aim is for you to see the browser and the web in a different way. I am bringing an agenda that I've been banging on about for the last, I think, 4 years now, so some of this might be familiar to some of you. I am back to talk about this. And I also want you to not be scared of hardware and microcontrollers, because this is actually really exciting. If you're a front-end developer, you now have the opportunity to have an excuse to learn more about this stuff and potentially start writing hardware drivers in the browser in JavaScript, which is really, really fun. So today we're going to be covering just a brief history of the web and devices and how we've done things in the past before this API, what WebUSB is and how that differs from our previous attempts at this, how to use WebUSB. I'm going to pray to the demo gods ahead of time so that they'll sort me out and be nice to me. So if we are lucky, there'll be some demos. And also just to talk about the futures of this and where I think that it is going. So first, the history of WebUSB, which means how do we use the browser to create an interface to actual hardware. And we've had a varied amount of approaches in the past. Some have been successful, some not so much. So my journey with Web and USB started in 2007. It started with Flash and a little thing called Flash Communication Server and SIR-proxy. So I'll explain briefly how that worked. Let's say you have a microcontroller. Let's stay with an Arduino, because a lot of you might already know what an Arduino is. An Arduino is a really, really, really great abstraction of hardware where you have a microcontroller that you can very easily plug things in and out of, and you can create really cool interactive experiences with it. So the Arduino, I think, came out around 2007, 2008 in Australia. I, of course, bought one immediately. And then I was like, how do I hook it up to the browser, though? Because I know HTML. But I don't think that Arduino talks HTML. So you install this program called SIR-proxy, which basically takes the serial port connection and the data coming in and out of the Arduino, and it proxies it to a TCP socket. So you can treat that stream as a TCP stream. And then you actually write your Flash file, and then you essentially write some Flash stuff in Flash Communication Server to connect to that socket and to be able to write to it and read from it. From there, you can just whack the SWF file that you export from Flash onto a web page, and you're done. That was quite a hack, though, to get that going. So here is just like some of the code. It's not super important. It's just for history and archaeological purposes. You have your ActionScript file where you're opening a socket to a local host. And with SIR-proxy, when you start it up, you give it a config file, essentially saying what port you want to listen to, what TCP port you actually want to open up, the baud rate of the device, and the bits and the parity and timeouts and all that kind of stuff. So it was OK, but obviously we know kind of where this journey went. In 2008, in Australia, we got the iPhone. I got the iPhone 3G. It was awesome, but it didn't run Flash. And so after a few years, Flash definitely went out of vogue because JavaScript started being performant, and there was some pretty major accessibility, performance, and security issues with Flash as well. So that kind of died for me as a way of doing things, because I was just kind of feeling like I was stuck in the past when I was doing it. So I believe it was in 2013, but maybe Matthias can correct me. I would love if someone could give me the actual date on this, but I think it was 2013 that a technology called Chrome Serial came to Chrome browsers. And so for a few years, I was actually playing with this. It was very, very cool. Unfortunately, I'll explain what happened to it later. OK, so we have the same scenario. We have an Arduino. We have a browser. And this time, we have Chrome Serial, which is basically an API that you could access very readily in the Chrome browser. And you use that in order to have like a way of reading and writing from the device. Oops. Then you actually have to have this within a Chrome app. I'm not sure whether it was security issues or what, but you absolutely had to use it in a Chrome app. But it was still cool, because if you could write an extension or an app, you could actually start talking to an Arduino in a browser. And this actually really had a huge impact on the JavaScript community, and especially people who were trying to write hardware cross-platform. Like, this is really where the idea of cross-platform hardware interfaces really started becoming a thing that were very, very compelling. So some of you might have heard of the chip computer. It was the famous $9 computer that was on Kickstarter. If you don't know about it, that's OK. I worked at Kickstarter at the time, so that's maybe why I know about it. But it was really, really cool. It was cheaper than the Raspberry Pi at the time. It was before the Raspberry Pi Zero. And it was essentially just Linux on a chip, but it was very, very affordable. And they did something that I was super impressed with. They used a Chrome app so that you could update the firmware on the actual chip. You could update the operating system on it, which was awesome. So you downloaded this really cool thing called the chip flasher, and you plugged in your chip, and you just started updating it. And I was like, this is literally what I've wanted this whole time for so many of my devices and for so many interfaces that I've wanted to make. So I thought that that was super progressive, and you can see how friendly that looks and how that's going to work on any operating system that can run Chrome. Shortly after that, I think last year or maybe the year before, Arduino actually came out with a Chrome app. This is kind of the web version, because I don't have a nice high-res screenshot of the Chrome app, but it is basically an editor in the browser. You can write your C++, and it will compile it, and it will flash it onto your Arduino, all directly in the browser using Chrome Serial, which is super magical. And they actually ended up using my library, AVR Girl Arduino, to do that. So I was like really, really excited to see that I was kind of part of this future. And it also made me maintain it a little more diligently than I normally would have. But I was just like at the peak of, yes, OK, so this is a thing, and we're actually proving it. So we're going to be able to keep Chrome Serial, right? Unfortunately, that didn't happen. So Chrome Serial was never like an official web spec. It was like very, very much in the Chrome kind of ecosystem. It only worked in Chrome apps, so you kind of had to create this whole big thing. So if you wanted to have a website that you could like interact with hardware, you kind of had to have this companion app or companion extension that people would have to install and then use your website. So it was a little bit awkward. And Chrome apps were sunset for every operating system except for Chrome OS in 2017, despite our many GitHub pleas. So that was just kind of a shame, but it really kind of got me hooked on the idea that browsers behave like operating systems these days, so there's no reason why we can't actually do this. So what do we do these days? Well, we still sort of lean on our good friend, the WebSocket, where our browser can be the UI, but we still need some kind of back-end service that can actually do the connection to the hardware, because the browser is very much locked out of that. So we've got our scenario as before. We can have something like a Node.js process. For those of you who have done Node-bots, that would be something like Johnny 5. That Node.js process would also have some kind of WebSocket that it also sets up from the back end, and it might also be serving that index.html at the same time as well. So it's actually doing a lot. Then you have this WebSocket where your browser can connect to it, and you're just kind of sending messages back and forth. So if the browser wants to do something with the hardware, you kind of come up with your own WebSocket communication protocol in order to do that. It is still not great having this kind of back-end coupling. It's just not the experience that it should be. And this is what makes people just go back to writing native apps, which brings its own challenges to it as well. So here is like an Electron app I made, which is sort of like the holy grail. Like Electron allowed you to combine those two processes together. And so I actually have the programmer right here on stage that I used to program this monogamous public radio. So this is sort of at the point where I sort of ended up quitting hardware interfaces in the browser, because Electron uses a lot of CPU resources because it's a whole Chrome instance, and it's also 110 megabytes. So people had to download 110 megabytes just to be able to change the radio station on this radio. And it just felt really excessive, but it was cross-platform, so it felt so good, but it just wasn't right. So I sort of just got burnt out. You know, it's been like, how many years has it been? Almost 10 years since I first started doing this, and so I'm just like, And you can actually still use the Arduino editor if you don't have Chrome OS. What it does is it just has this background app that runs in your taskbar, and it is using a WebSocket. I was debugging it last night. It just kind of uses that very same architecture, so that's another example of something that uses that. So now that we've had a look at all the failures that we've had at trying to get this stuff going, what is WebUSB itself? Because it's pretty different to all the other approaches that I showed. So the WebUSB spec is actually really cool. I've been following it over the last few years, and it's definitely gotten fleshed out. The introduction part is written in human text, not spec text. So I promise I'm pulling a lot of this from the spec because it is actually really well written. So the WebUSB API provides a way to safely expose USB device services to the web, which is pretty cool. It provides an API familiar to developers who have used existing native USB libraries, and exposes the device interfaces defined by existing specifications. So this is really awesome, this particular point here, because no one's reinventing anything. You can expect to, if you've ever done low-level USB drivers before, and again, it is possible to do it in JavaScript. That's sort of what I've been doing over the last few years. You will be pleasantly surprised that a lot of your stuff ports over really easily because they haven't tried to reinvent the wheel and come up with a new API. You're still doing things like control transfers, which I'll show you later, and claiming interfaces, and it feels very much like a regular low-level USB experience. So I think that was a really important thing that they did. It does make it harder to get started, but I think that a lot of people are going to be releasing abstractions to help out with this pretty soon. I'm hoping to find the time to do so. So it's important to kind of tell you that WebUSB is not the same as serial. So a lot of devices, such as the Arduino and other things, they have kind of a USB to serial like chip in between that kind of tells the machine that it's just a serial port that you can access. So it's actually not really a one-for-one replacement of something like Chrome Serial or like Node Serial port if you've used that with Node bots. It's not quite the same. You can sort of get stuff working, but you do have to provide some shims and you sort of pretending it's serial. But I'll show you an example of that later on as well in the demo. But OK, so if it's not serial and things like that, other than the regular USB interface you're used to, why is it better? Well, I really like that they called out that it's kind of a safer way to connect your browser to devices. So the first thing you get is if the user actually has to initiate the connection event themselves. So someone can't just go to your website and then you immediately start polling all their devices and trying to hack them. It actually just doesn't happen like that. So someone has to physically give permission, like clicking a box or having some kind of keyboard event or some sort of user-initiated thing. And even then, it pops up this really nice little modal that says, like, you know, this website wants to connect to this device. And so you then have to physically click on that device and click connect. So there are multi-steps there similar to things like your webcam and all sorts of other permissions you've probably had, such as news websites wanting to send you notifications, and you always click the block button. It's very similar here. You can actually click cancel, and you don't actually have to take action, which is cool. The other thing is there's this really neat hook that they've put into, like, you can put this in your device descriptor on your actual hardware itself when you plug it in. You can already suggest a website that people can go to. So as soon as they plug it in, Chrome can helpfully pop up a little notification saying, hey, I detected this device. Like, you probably want to go to this website to start, like, interacting with it. And if you're curious, fragile.systems is my new domain name I just registered this week for all of my really crappy duct tape demos. So if you see any of my stuff with .fragile.systems, just be aware. It's not perfect code, and it's probably pretty terrible. So yeah, but you're probably thinking, like, Suz, why are you trying to use the browser for everything? Like, you've got this hammer, and you're trying to, like, knock all the nails in, and half of them aren't even nails. Like, what are you doing? And honestly, it's because I've had to create hardware interfaces before outside of the browser, and they're not fast to make. It's harder to make them cross-platform. It's hard to make them look good, and a lot of the kind of native UI shims for things like Qt and that, it's hard to make it accessible out of the box, or at least I've struggled with that. And so I believe that hardware interfaces shouldn't be left out of the experience that we have as front-end developers, where our stuff is fast to make, it's cross-platform out of the box, it looks good, and it's accessible. And so browsers are a commonly installed application on a lot of computers. Technically, this could probably be used offline if you, do your service workers right and things like that. That could be really cool. Browser-based interfaces, like I said, are rapidly prototyped. You can hot patch that easily. You can just deploy a change, and the user just sees it the next time they go to the website. CSS is incredibly powerful, as we saw yesterday at CSSConf. And you get a consistent accessibility tree because you're accessing the browser's accessibility tree. So that's always a win as well. And also, I really liked this little gem in the web spec that convinced me that maybe I wasn't the only one, that with this API hardware, hardware manufacturers will have the ability to build cross-platform JavaScript SDKs for their devices. Doesn't that sound fun? Like, you buy a device and you're like, yeah, download the SDK and just start futzing with it in the browser. I think that would be really cool if they started shipping that. Cool, so how do you use WebUSB? How much time have we got? We're good. All right, so you've got your user, you've got your browser, you've got your device. They plug the device in. They are invited to go to that website, so let's say that they're already there. They click something like connect or start or something like that. And that user event click is going to go to the browser, and from there we can actually access the USB API. So the browser will then actually look for devices, and you can give it a filter so that you're only really looking for one particular device. Once it's found a list of device matches based on your filter, it will return that to the browser, and then the browser will then pop up that modal that we saw asking the user for that additional permission to actually get started. Once that user confirms that permission, then we can actually start getting the ball rolling. So that's where we can open the device connection formally. We can select the right configuration that we want. We can claim the interface. And then once we've claimed the interface, we have the in endpoint and the out endpoint, and we can just start reading and writing, which is really, really fun. So this is all well and good. This is a nice abstraction, but what does this look like in code? So this is as short as it can get to get started. You supply some options when you're actually requesting some devices. So here I'm just giving a filter, and I'm giving a vendor ID. So most products that you buy off the shelf have a product ID and a vendor ID. And so the vendor ID is obviously unique to the the company you're buying the device from, and the product ID is like for that specific product itself. So you can filter on both vendor ID and product ID, and you can be really, really specific about what device you want so that they don't accidentally pick the wrong one. So that's pretty cool. So once you've actually supplied that filter, you can just call navigator.usb.requestDevice. You put in the options so that it knows which ones to look for. And if that comes back without any errors, I know that I'm not catching my errors, I'm sorry. You can console log, basically you can get the device product name and the device manufacturer name immediately. So when you first plug in a device, you can read descriptors and stuff, and you don't necessarily have to have an open connection to it yet. So you can actually glean a lot of information about a device even before you start opening it. So this is kind of the hello world of WebUSB. As you can see, it's not a lot of lines to get started. You do have to wrap this request device in like a user event. So you would probably wrap that in a button.add event list and a click or something like that. It gets a little more complicated, and this is sort of where sometimes you need to be familiar with the device that you're interacting with. But we went back up to the top, so we requested the device. That is a promise that resolves once the person has actually given the permission for the device. After that, we can open it up because we have permission. We select a configuration. I don't really have too much time to go into these things because they tend to be more the actual USB spec itself, not necessarily WebUSB. But if a device has several configurations, you choose the one that's right for you, and it's just offering different endpoints and things like that. And then you claim the interface, which means that you want to take priority control over the device itself. So if any other process on your computer tries to interact with it, it's going to get locked out. So it's really just saying, this USB device is mine. And then you claim the interface that you actually want. So sometimes there can be several interfaces that a device offers as well. So definitely check your datasheet, and I'll show you an example of what that looks like, because don't just guess the numbers like I was a few days ago, because as, as my friends saw, it was not a good experience, so I actually dragged out the datasheet. Then after that, once you claim the interface, you can actually start transferring things out, and you can wait for responses to come back in. So the first argument of transfer out is the endpoint you're transferring out to, and then the 1A hex is just like the byte that I'm sending. And then if we want to receive data, we just say transfer in. We give it the endpoint that we want to read from, so that's number 2 in this particular case. And then we want 5 bytes. So there's not a lot of stuff. You just have to know where those interfaces are, really. And again, your data sheet will tell you that. And then you can just console log out your response. So that's pretty good. If you already know the language that this device speaks, then you're off to the races. So this is sort of what a data sheet, this is a screen grab of a data sheet. I freaking love data sheets so much. They're like one of my favorite things. So this data sheet comes from this programmer I have up here that I'm going to demo later. But you can see all these descriptors and stuff. I just looked up those details in the tables, and I was then able to, from there, pick the right interface, pick the right configuration. It gave me literally the number of the endpoints and everything. So it's all pretty human readable as well. The bottom in the table, the bottom property there says num configurations. It literally says how many configurations there are. So you know in this case, if there's only one, then you're just claiming configuration 0, right? Because that's the only one, and we're all index 0. So that kind of stuff can be really illuminating. Just get comfortable reading data sheets. I promise they're not as scary as they look at first. Yeah, so I haven't really done a lot of hardware demos for a little while, but WebUSB got me excited enough that, yeah, I'm back, and we're going to do some really fun stuff. So that means some demos, just to show you like the power of WebUSB to get you excited, because this was all very dry, like very spec sort of driven slides. But I have to give you a disclaimer first. So WebUSB, this is kind of like Snugug yesterday. He was having to say this about Houdini. WebUSB is not super stable right now, so stuff keeps randomly breaking. It worked before the lunch break. I can't give you any guarantees it'll work now. Everything I've made with the WebUSB is definitely duct tape city at the moment. I have duct tape on stage here. Well, it's not quite duct tape, but there is tape holding my webcam up. The second demo I actually wrote on the plane offline, so just bear with me, but I think it's going to be really fun. So let's have a look at some demos. So I'm going to bring up my camera. So can everybody see that screen right there? Cool. All right, so I'm going to plug the first device in. So the first device is what you're actually looking at. It is an Adafruit Feather 32U4, and it's just, you can pretty much swap this out for a regular Arduino with a 32U4 chip. And I've plugged in what's called an OLED screen, of which I've written drivers for, so I cheated and I used some drivers I'd originally written. So I'm going to plug this in, and we'll see if anything actually happens as it's supposed to. This is always the nervous part. OK. Cool. Yes. OK. So see that popped up there. It's kind of hard for me to zoom right now because I have a lot of stuff going on my screen, but it says Feather 32U4 detected. Go to webusb.fragilesystems to connect. So I'm going to click that. All right, it loaded. Thank you, Snugug. He helped me write a rainbow gradient as the background for my, for my demo this morning over breakfast, so I'm very thankful to him. So I think everyone can see that, so I'm not going to zoom in anymore. But this is a virtual copy of my screen on the web page, and then we have the real screen here. So we can have a lot of fun. So we can actually like draw stuff, right, which is pretty cool. But I have some pictures that are readily made, like kind of like turkey.py this morning. Thanks. That was really awesome this morning, this talk. OK, so what can we pick? Let's do a cat. Cats are cool. OK, so that's a pretty neat cat. And let's see if we can actually send it to the screen. You can tell I'm getting really nervous. OK, so we connected. You just saw this kind of wipe thing happen. That's just the screen booting up as I connect to the device. So that seems to be pretty good. So if we click send image, hopefully we'll see. OK, so you may see a reverse cat come up because, oh, no, wait. No, we fixed that. OK, it's fine. Yeah! All right, what else have we got? Oh, I took Tim's picture from the speaker page. Sorry, Tim. So there's like a dithered version of Tim. So I'm using like the Floyd-Steinberg algorithm to kind of dither it, but you can use like the Game Boy algorithm too. I call it the Game Boy algorithm. What else have we got? We got JSConf. Yeah, let's send this one. Yeah, okay. All right, and I got one more for you. This is a very special one for all of you out there who have been on Twitter recently. Yeah, we should have a radar smoosh. Awesome. Cool. So as you can see, it's pretty quick. We are doing a little bit of fandangling with like fake serial / WebUSB and things like that. I'm going to cover the tools that I use to make this later on. But that's kind of an idea of how much fun you can have with this kind of thing. And by the way, the actual this actual interface here where you can draw and stuff, which I'll just prove to you is actually working. Yeah, so that was actually made by my friend Rachel Weil, Partytime Hexcellent on Twitter. She created this really cool thing called OLED.js Designer, and I've just been like hacking it into everything I can find right now. So yeah, so that's awesome. Thank you so much. All right, so that was the first demo. That's pretty cool. But I sort of thought I could do something really dumb, and I thought I could do this thing where, so I have an Arduino here, right? And it's just an Arduino Uno. I'm sorry for those at the back who can't see. And I have this AVR ISP Mark II programmer plugged into it. So this is kind of how you can use WebUSB to flash an Arduino, even though you would normally need a serial interface for it. So this is kind of me cheating and using a WebUSB device to flash an Arduino. So I didn't quite get it working, but I kind of want to show you like how cool the interfaces you can make for this kind of stuff. So this one doesn't pop up with like a website or anything. Whoa, I'm losing my phone. OK. So this one doesn't actually pop up with a cool notification, but I'll take you to the local website where I have it, because I only have a couple of minutes left. OK, so hopefully this is still running. It is. I got inspired because I found the very first website I made recently on a floppy disk, and it made me so happy, so I just thought I'd do something nostalgic for this demo. And that website was like 18 years old. It was unbearably dorky. OK, so I'm going to connect to this AVR ISP Mark II, and luckily 4 years ago I wrote a JavaScript driver for it. So I've sort of been trying to webpack everything now, and this just doesn't work very well when you're on a plane with no Wi-Fi. All right, so I'm going to connect to, ooh, it's doing it. OK, so what it did was it grabbed the programmer signature, AVR ISP Mark II. It then asked for what microchip signature I have on the Arduino. And then it showed me my fuses, and as you saw there, it was actually flashing a program straight to it. So every time I'll do it one more time. Every time a page of memory, so I think for this chip it's like 128 bytes. Every time 128 bytes is successfully written, it does a little thing on the progress. So I'll just show you that one more time, because I think it looks really hackery. But this is the kind of interfaces you can make for hardware now. It's so much cooler than what you've probably seen out there. All right, cool. So it's writing pages, writing pages. This is just like using a regular custom event emitter, which is pretty chill, and then it's done. So that's pretty cool. So the catch with this is my array buffers are showing really weird bytes right now, so the device doesn't actually boot, because I think it's writing stuff to slightly wrong page addresses, but I'm still figuring it out, but I thought I would show you the progress of that and how much you could depart from normal hardware interfaces. Cool. So that's pretty sweet. So the first demo was made with basically a kitchen sink of items. I used WebUSB serial from my friend Lewis. He sort of created a shim, and then you can upload a nice script on the Arduino to kind of act like that sort of. There's a shim on the Arduino, and there's also a shim with JavaScript. So I forked his project and just kind of had to like refactor it slightly to work for mine. I'm using Johnny 5 to talk to the OLED.js screen, and that's because the OLED.js library that I wrote actually just uses a Johnny 5 instance in order to connect to that screen. I'm using PNG to LCD, which is a library of mine that does the Floyd-Steinberg algorithm thing to combine, to do images. I'm using OLED.js Designer, as I talked about, my friend Hexcellent, Rachel Weil. That was for my first demo. And lots and lots and lots and lots of web packing. But I'm sure we're all used to doing that by now. Demo number 2 was made with AVR Girl SDK 500 version 2 and AVR Girl ISP Mark 2. I apologize, they're just communication protocols. I just went to the spec and implemented them. So this is the kind of stuff you can do now in the browser. And then I used Webpack, and I just wrote really, 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 really bad code to get that going. But it seems to be promising so far. So hopefully I'll have that working, and I'll be able to blog about that soon. So futures. Current support, not great. Not great. And I will admit, I've been guilty of swinging by the Redmond campus. I actually live in New York, but I'll go by the Microsoft Redmond campus, and I've literally gone peddling WebUSB devices. And I've said, hey, can you give this to this person on the Edge team and this person on the Edge team? So I'm trying. I'm doing my part at Microsoft, but right now, it actually amazingly works on Chrome for Android, which is cool, but it's really just for Chrome right now. So I'm hoping that more browsers pick it up soon, but that is 56% of people globally. So why support this then? Well, I really like, again, the WebUSB spec said, this will be good for the web because instead of waiting for a new kind of device to be popular enough for browsers to provide a specific API for, we can just build it from day one, which is pretty sweet. So if you wanted to get started with an Arduino and WebUSB, which is probably the easiest way, even though it's definitely the most hacky way, have a look at both the spec, this Arduino example, which is a pretty easy to remember URL, and if you wanted to check out my first demo, I've pushed the code to that address there. So hopefully this got you excited about WebUSB. I'm very excited, so I hope to see more open source samples of people playing with this kind of stuff. Thanks.